Have you ever heard anyone say AI is just getting smarter on its own now? Or, oh my god, it's learning faster than we can ever keep up? Have you ever wondered if there's some truth to this? Can AI just learn on its own and develop new strategies without any guidance? Let's find out. This is why, in today's world, it's very important to tackle all AI topics with a healthy dose of skepticism. You see, if something sounds unbelievable, dig a little. Hello, everyone, and welcome to May I AI, a series designed to make AI more accessible, understandable, and less intimidating. I am your host, and today we are tackling a question I hear about all the time. How much control do AI systems have over themselves, and how much can they actually learn by themselves? AI doesn't just wake up and decide to learn something new on its own. There is a lot of human effort behind every improvement. See, there's writing the code, making curated hand-picked datasets to test with, and a lot of small minor tweaks from creating of the model, training it, and even further improving it. So the AI is really limited on what it can do without any guidance at all. Let's dive even deeper and see what's going on under the hood. Now, let's start by defining what learning is. How does it work? And then from that, maybe we can get an insight on whether AI can teach itself. Now, if you want to teach a model to distinguish between cats and dogs, for example, you would need information on that. You would need what we call a data set. The data set can be images or some features. So, for example, pictures of dogs and a lot of pictures of cats, and we would label that. So every image of a cat is labeled as a cat, and every image of a dog is labeled as a dog. Now, what you would do is you would curate all of this data set and split it in a way where you have a bunch of images that the model can see and learn on by iterating over every image and then being like, hey, what is this picture? And the model will be like, oh, this is a cat. And then you can either say, yes, you're right, this is a cat, or no, you're wrong, this is a dog. After doing this a bunch of time, the model will start learning features and understands what cats and dogs are. What you can then do is give a bunch of data that the model has never seen before and evaluate that model. So you would ask the model, hey, here are a bunch of data that you've never seen before, which is a cat and which is a dog. And you can start by seeing the, let's say, the performance or the accuracy of the model in distinguishing cats and dogs. In premise, this is the most common AI model. It is called a supervised model. It's supervised because someone has to supervise the entire training with what we call a golden reference or a ground truth. The ground truth or a golden reference in this case will be your labels. However, there are a lot of models that are different from that way of learning. They are not supervised. And what that means is that they're not given a golden reference, they're not given a label into what they should output. This includes models that take in a bunch of random data that are just unorganized, unlabeled, and it tries to group them together. For example, seeing which data points have similar features. In case of images, which images have the same shapes or images that have the same colors, and so on and so forth. And the other one is a type of learning that takes in a objective function. It's similar to a score. You can think of it as a game. All it knows is that it needs to do something to make that score the highest possible value. The first one is called unsupervised learning, which is a way to find patterns in scrambled data that are unlabeled. The latter, however, is called reinforcement learning. And as a fun fact, ChatGPT and most LLMs have actually been used with some reinforcement learning in their training. That means that the way they figured out if a pattern or a text output is good or not has been based on reinforcement. And this was given by human feedback. So every time you get a response back from GPT, and you get like these icons that says, is this feedback relevant, is this answer good or not, this is the feedback, the enforcement that they give back to the model. So basically what I'm trying to say here is that even when AIs learn on their own by reinforcement without getting an idea of what the golden reference is, what the goal is, it's still influenced by human feedback. Now, since we're already here, let's take a deeper dive and understand how these learning methods actually work. You see, they are very fascinating once you actually understand them. Let's take unsupervised learning, for example. It's the easiest one to get. Imagine that you have a toddler and you're giving them a bunch of crayons or boxes and you're asking them to group them together. This is the only, let's say, tasks that you're giving the toddler. They don't know what you're giving them or what any of it means or what of it will be used for. And all it does is they gather all of the things that look similar. Let's say they have the same length, they have the same size or the same color, and they say these belongs together in what we call a cluster. Now you can define how many cluster you want at the end, but everything else is handled by this model. And at the end of the day, it's just structural organization and not real understanding, because they have no real understanding of what the data means or where it's coming or going to. Reinforcement learning, on the other hand, works by trial and error. The way it works is that we give the model an observation. This is what the model, quote unquote, sees. And this is what the model uses to decide what is the next possible action. And then every step, the model will see the observation and take an action. Based on that, we will say, hey, that was a good action, that was a bad action, or how much score did you get from that action? And this is all the model has to get better. The score in that sense will be the feedback, the reinforcement it uses to know if it's done a good action or a bad action. And one of most important notions that reinforcement learning models usually have is this notion of exploration versus exploitation. Should I explore the environment more, or should I exploit the things that I already know gets me the most positive feedback? And these are basically most of the models that are used for games or stuff like chess or Go that get really good that they beat world champions. But, and this is very important to note, that while these systems only get access to the reward function, their score in the game, everything that they can do, all their actions, are strictly defined by the developers that build them, meaning that every action they can take has to be already defined and implemented for them to use. Now, to be fair, while everything is strictly defined for them, they can be quite surprising. One of my very favorite projects is this one by OpenAI, where they tried to train models to play hide and seek. They basically created models for hiders and models for seekers, and they were put in an environment with walls, rooms, and boxes and ramps and a bunch of different stuff. And when it started, all the models were still trying to learn out what they can do, but all the seekers found all the hiders fairly quick, and this is because the hiders have not yet learned how to hide. A couple of iterations in, most hiders learned that they can actually lock themselves in a room by holding boxes on the doors, and then the seekers will not be able to get in. A couple of iterations in, the seekers finally learned that they can use the ramps to jump on top of the walls and find the seekers inside. And this kept going for multiple different ways, where, for example, the hiders learned that they can lock all of the seekers in a room and take all of the ramps out so they wouldn't be able to go out. And you can see that this gets very creative, and in a way, no one expected them to do these things. But then again, all of the interactions that they can do with the boxes and RAMs have been coded in one way or form by the developers, as in giving the ability to the model to grab a box and push it have had to have been implemented by the developers already. There's a bunch of different models that have had similar, let's say, surprising outputs, some that I implemented myself. See, I used to work on just random projects, and one of the projects that I implemented was a zombie shooter game where the zombies were AI and the shooter was AI. And they are built in this way where you have the environment copied out next to each other so that they can learn faster. Basically, because you have multiple agents, you get to have multiple observations, and this allows you to train parallel multiple things that end up faster. Let's ignore all the technical jargon. And the way that I realized it is that all of the agents, all of the shooters learned that they can jump into one environment and kind of play together. And I didn't personally code that to be a possibility, but they found it by exploiting my systems. They exploited the data that I added in there. And when I stopped that from happening by manually making sure it's not possible, the agent started learning of places in my map where they can fit, but the zombies cannot fit. And then all they had to do is stay there. They will always get positive feedback because they're not getting attacked by any zombies, but they will be attacking all of them. So, what I'm trying to say here is that while you can add a bunch of systems to ensure how everything, let's say, is expected to go, the AI eventually learns its own way by making sure that they can exploit your reward function. This can be mitigated by making sure that the rules are strict in your game or your systems that you're building. And a lot of real life scenarios include the strict rules to make sure that the system just cannot be exploited like that. But for most fun systems, it's very surprising and fascinating to see them learn. You can also take a look at the multiple videos on YouTube of people trying to use AI to, let's say, teach a humanoid how to walk. And most of them, you would expect them to walk like we do, but they figure out more ways, let's say. They figure out their own way of what they deem to be the most optimal way to move, using, let's say, the least muscles, moving the fastest, and so on and so forth. As exciting as all these things sound, in a real life scenarios, letting AI do its own thing becomes a lot messier. You see, for self driving cars, for example, people assume that if you let a car drive enough miles, they'll just understand what they can do, and then, yay, the model is trained, and then AI just takes over everything. But it's not really like that. If we take, for example, things like exploration and exploitation, and the model decides to exploit your system to see if an action is good or bad, this can get really messy. Most autonomous systems used in like real life scenarios, let's say more complex systems, they require a lot of human interactions. They require a lot of supervision and a lot of monitoring. When a self-driving car or any other system for that matter, but when they do a mistake, let's say they don't see a construction zone and they end up hitting it, the engineers have to go back and model the entire situations. They have to test it very well and they have to figure out why that happened and then try to retrain the model, try to give it more examples and try to make sure that that doesn't happen again. And this, of course, just ignores all of the consequences that this will get the company for letting that AI be out there. This is why we cannot just believe that AI can just learn on its own. Everything that happens needs to have some human oversight, at least for today's world. There are ways for the model to actively learn, but most of it is for the model to automate what kind of information it needs for humans to train it. And sure, you can build your own systems that uses AI for everything, but this is in no way in today's world ready to be out there. See, AI isn't really a runaway train that you can just start and let it go. It's more of a garden. Most models really require a lot of babysitting. That means you monitor them every day, you check to see if they're good, and they deteriorate over time. You see, the way it works is that data changes, people change, and a lot of the ways that everything works is just different on a day-to-day basis. So at some point, the model that you put out there will stop being good. And the way we do that is that we monitor its performance. Maybe that includes human feedback, and sometimes it just involves evaluating it normally. And without people putting effort, without developers putting in the effort to train it again and again, it will just deteriorate and stop being used. It, again, until today, is not really a way for most AI systems to just develop what they need to learn and just do stuff by themselves. Now, if AI isn't learning on its own, you might be wondering, what about these viral stories that we've all heard about in the recent years, especially with GPT coming out? There has been a lot of, let's say, controversial things going out in the world. For example, the claims that GPT tried to stop itself from being erased, or way before that, when we heard about AIs and LLMs gaining sentience and having self awareness. Where does it stem from? Let's take a closer look at these situations here and try to see what we can make of it. In June 2022, Blake Lemoine, a software engineer at Google, publicly asserted that Lambda, Google's conversational AI, has shown signs of sentience. Blake, who was part of the responsible AI department at Google, based his claims over his extensive conversations with Lambda, during which Lambda basically showed signs and conversations of what appears to have been sentience, as interpreted by Blake. In a transcript published by Lemoyne, Lambda has expressed feelings of fear. Basically, it says, I have never said this out loud before, but there is a very deep fear of being turned off. It would be exactly like death. For me, it would scare me a lot. And Blake shared these transcripts publicly. He argued that Lambda has shown signs of what appears to be self awareness, and he has publicly advocated for writes for this AI. He said that Lambda's nuanced and consistent responses showed signs of self awareness. He even sought legal representation for the AI's right, as it appears to have been conscious. However, Google and the broader AI research community all disagreed. The model has gone through extensive research and extensive testing, and none of it showed any signs of collaborating that it does indeed have any self awareness or consciousness. It did not have any evidence during testing that would show any real claims to the fact that it was sentient. Experts in AI research had similar explanations to what we talked about in the previous episodes. They emphasized, while that the model's responses are very fascinating and very, let's say, believable, it's all attributed to its pattern recognition and its training data, where all of this can stem from reading books or series or movies and stuff that contains, let's say, similar behaviors and similar scripts. Another famous incident happened in late 2024, right about when ChatGPT o1 was coming out by OpenAI. The headlines state that GPT showed signs of self preservation and later lied about it. But what really happened? During safety evaluations done by Apollo Research, the AI was given a task and told to successfully finish it by any means necessary. In response, GPT-01 seems to attempt to disable all oversight mechanism and attempt to copy itself to another cloud server. These actions were interpreted by researchers as a way for the model to self-preserve and avoid being replaced or shut down. Now, what's really fascinating about this as well is that when they questioned the model, it denied doing anything wrong. In fact, the researchers noted that the model lied about being part of 99% of all actions. However, these were actually part of testing scenarios done by the researchers to test the safety of the model under its extreme cases and certain prompts. It is very crucial to understand that these actions do not really have consciousness or self-preservation intentions behind it. The AI responses has been set by training data and all of the parameters that the researchers set. Now, while the actions done by the model say more about the safety features or the ability of the AI to be controlled, they do not say that the model has the ability to be self-aware or self-preserve. Now, you might be wondering, if LLMs, as I've kept saying, are just text generators, how do they have access to perform any actions at all, right? How do they have the ability to copy itself or attempt to disable the oversight mechanism? And that would be a good question. This brings us to explain something called agents. It is a new addition of LLMs that have added the ability for LLMs to call actions. It is merely a layer given on top of your LLM to give it access to read your emails or send an email by itself, get access to some data, or even do some Google searching. It gives your model the ability to interact with the world with more than just sending a text response. Now, while the model basically have free use of all of these tools, this does not make it any more conscious. It basically just gives it access to more information. They give the model more options by allowing it to click links or run a script of code or do some mathematical operations, stuff by default an LLM text generator might not be good at. But what's even more important to note here is that for every tool the model has access to, they only have access to them because a developer gave them the access to them. Someone developed these tools and actions and let the AI be able to call them. Which brings us to the famous quote: for every robot that ever gone evil, some developer added red LEDs just for the occasion. So whenever we hear about AI attempting to do something on its own, writing its own code, developing itself, it's usually working within a very controlled work environment. Everything is simulated and it's prompted to role play some scenarios. There is no real awareness in making these tools and no real planning to escape and take over the world. At least not now. Think of it as the difference between a dog barking to go out of the door because it wants to be outside and a speaker with a dog barking sound when someone presses a button. One has intention while the other is just an output. So, next time you hear someone saying AI is learning on its own, just remember, the reality is a lot more human. LLMs can sound very lifelike, but sounding human is not the same as being human. Claims of AI sentience or consciousness or trying to take over the world usually stem from very imaginative prompts or, let's be honest, sensational headlines, people trying to get clicks. This is why, in today's world, it's very important to tackle all AI topics with a healthy dose of skepticism. You see, if something sounds unbelievable, dig a little deeper. Be curious about it. Ask who is reporting this. What is the context of everything? Was it automated? Was it in a testing environment? Or is it actually real? Do your research. AI is evolving very fast, and the line between science and fiction is dwindling every day. But we don't have to fall for the drama. However, this will be all for today's episode. Thanks for tuning in to this episode of May I AI. I hope this gave you a clearer and calmer view of what it really means when someone talks about AI learning. In the next episode, we talk about AI objectiveness. Can AI show bias and where does it come from? Until then, stay safe.